Our project is about wireless ECG monitoring system. Before I'm going to talk about the project, first I'm going to talk about the multiplication. As we all know, the percent of the people in the United States who have a heart problem have been increasing every day's life. We are experiencing friends and relatives who are suffering from the heart problem. They have to go to the hospital for checkup regularly. They are also afraid that their heart might stop working at any time, and at that time, nobody is nearby to help them. Therefore, we decide to build a project that would help them do the heart test. Our project is about, now I'm going to talk about the general idea of what is ECG waveform. ECG waveform is electrocardiographic with record a graphic of electrical activity of the heart require the patient to that capture the electrical activity of the heart over time by electro skin to skin. It also detect and amplify the tiny electrical jar on the skin. We use 3 electrodes, one on the right hand, one on the left hand, and one on the leg. The waveform, the normal ECG waveform component. We have several different components. P waveform, PR interval, QR complex, ST segment, T wave, QT interval, and U wave. It depends on a human. Everybody have different ECG waveform, and only a specialist doctor would be notified if the patient is having a heart problem at that time or not. Therefore, we decided to build our project which can transfer the ECG waveform from the patient to the server where the doctor can analyze the ECG waveform and to know that if the patient is in a safe mood or needs emergency immediately. So here's our project. Our project has 4 main components, which is ECG waveform processing circuit, authentication, data transmission, and iPhone. ECG waveform is for ECG waveform processing circuit. We use that to capture the ECG waveform of the patient and then transfer it to the iPhone using Bluetooth. After that, the iPhone application will use the data that we capture the ECG waveform and transfer to the server where the doctor can monitoring on the computer of the waveform and notify if the patient is in need of help. That is the project overview. The advantage of this project is the freedom of the patient. The patient doesn't have to go stay in the hospital every single day or go into the hospital for checkup regularly. They also can travel around because the doctor can be able to modify their heart behavior at any time, at any real time, but they don't have to be next to the patient. However, it's very low cost. The device is not expensive to build compared with the money the patient has to spend to stay in the hospital or to go to the hospital regularly for checkup. But however, if the patient heart suddenly stops beating or any problem happen to it, and nobody is nearby, like such as when the patient is home alone and at that time they couldn't reach the phone and call 911, the doctor who monitor the heart behavior can notify immediately and will send and will make a call to 911 so emergency would come by and help them help the patient immediately. The next part will be ECG waveform processing, and my team member Nam will talk about it.
Talking about ECG waveform processing. You know that ECG waveform processing circuit is the first step to take the ECG signal from the patient. And the ECG signal is very small and millivolts is the low frequency, the rest of 0.05 hertz to 130 hertz. And with this small input, we have two columns. So first we need to provide minimum gain of 1,000 to get the output range of 2 to 3 volts. And then next we have to reduce the noise together with input here like thermal noise, shock noise, critical noise, and interference. And to satisfy this requirement, we determine the specification of the circuit as well. We basically deal with low noise part, and the circuit can give a high gain and a high performance CMRR to reduce the terminal of the signal. And we basically dissipate low power, and it can limit the bandwidth from 0.5 hertz to 100 hertz. And the circuit can remove the signal from the power line frequency. So the circuit consists of three components: implementation, amplifier, and fast filter, and signal filter. It's a complete circuit. Now that I talk about the circuit in detail, first for instrumentation amplifier, we use the 8628N6 because it's the low noise part, and it's the very excellent high performance CMRR, and give a high slew rate and low power. So we can use battery in this device. And battery we can set the gain from 1 to 10,000. But here we limit the gain 1,500 with the resistor equal consider. And for a band fast filter, we use OP 177 with a low noise, low frequency of amp. And here we combine the low pass filter and high pass filter to get to limit the bandwidth from 0.5 to 127 hertz. And last step, we build the notch filter. Here, because we can use this device in the city cross power supply environment, maybe the possibility interference very high. That's why we installed this filter in the device. And here we use unity notch filter, and this filter can remove the city cross frequency. And because bus filter has a quality factor very low, and we add the voltage